come across a question, a very usual problem, that is there is a bullet of small m coming with velocity. There may be some numeric value which may be given to you, that is mass is 10 gram, velocity is 500 meter per second, and from a string there is a block of 10 kg or 1 kg which is hanging over here. We have taken it as a capital M. So this is coming horizontally. Then what happens is this gets embedded into it, into this wooden block, and as a result this block, it moves up over here with this small m embedded into it. What is this height to which it is going to rise? What is this height to which it is going to rise? Always remember, whenever there are collisions or explosions, the very first thing you are going to use is conservation of linear momentum principle. We have not done till now the rotational mechanics, we have not done angular momentum, so we are just talking about the linear momentum. Whenever there are collisions or explosions, always the first choice is to use the conservation of linear momentum. Why? It is, we know F is equal to dp by dt, rate of change of linear momentum. If this comes over here, F dt is equal to dp. Collisions and explosions, they are instant. That is, time is almost equal to 0. So dt is almost equal to 0. So if this is equal to 0, so change of momentum of the system is equal to 0. When the change of system momentum is equal to 0, it means momentum is conserved, it is constant. So that's why we use conservation of linear momentum principle whenever there are collisions or explosions, because collision and explosion, they are instant. Just at one instant, there are so many changes they are there. So over here, first thing is, when it strikes to this, then at this instant, momentum before collision is equal to momentum after collision. That is P, we say before collision is equal to momentum after collision. We'll come to that. This is purely when a body comes over here and collides with the second body, and both the bodies, they move with a single velocity. That is the case of perfectly plastic collision or perfectly inelastic collision. We simply use conservation momentum over here before collision. The momentum of this is mass into velocity, and momentum of this body, we have a system of this plus this. So momentum of this body before colliding this is mass into velocity plus momentum of this was initial state stream. So m into 0 is the momentum of this before collision, is equal to momentum after collision. Momentum after collision, what is the momentum? That is, both of them, they are moving as one body. So m plus small m into, let's call it as v dash. So now the combined velocity of this block with an embedded bullet is going to be v dash. So this is moving with v dash velocity. So v dash we can calculate. So it is small m into v over m plus m is equal to v dash. So far it's okay. Now from this position, once it has got embedded, and when it gets embedded into this, then obviously the heat, energy, etc., they are also produced. Momentum is conserved. When we say momentum is conserved, that doesn't mean that its kinetic energy is also conserved. There are going to be losses of energy, that is in terms of sound energy, in terms of heat energy, there are going to be losses, but the momentum is going to be conserved. So, but once this has got embedded into it, and these two, they are moving at a common velocity, now from here to this position, we can easily apply, comfortably apply the conservation of mechanical energy principle. That is, whatsoever is the kinetic energy over here, that purely gets converted into the potential energy. It has risen over here, the kinetic energy over here of the system is equal to 0. So whatsoever the energy this system had, the all has been converted into the potential energy of this. So we have a single block system, that is, both of them, they make as one system only. We don't have two blocks and a pulley, etc. So this one mass of m plus m, initially it has a kinetic energy over here, the whole gets converted to potential energy. So if we talk about losses and gains, so when it goes from here to here, what is the loss? Loss is kinetic energy. How much? Half m plus m into v dash square, kinetic energy, is equal to, obviously, mass will be given, m will be given, v will be given, m will be given. So you can calculate, v dash can be calculated. You put the values and v dash is calculated. You can find the value if the numerical values they are given. So once v dash is given, so it means loss is known. Half m plus m into v dash square is equal to what? Is equal to gain of potential energy. Potential gain is what? M plus m into g into h. From here you can find the value of h.